Hello, everyone, and welcome back to the Validity Podcast. I'm your host, Valentina Rodriguez, and this is officially Season 2, Episode 4. I literally just recorded Episode 3 because I'll be traveling, so we're literally going to get straight into it. I don't have any more personal updates other than the ones I just gave, like 45 minutes ago. Still 7 weeks, 2 days post-show. Still recruiting for the world's first reverse dieting study. So email reversedietstudy@gmail.com if you're interested. Still just in the midst of PhD applications. My second and last year at USF as a master's student. Still live, laugh, loving life, killing my reverse, all of the above. Just filmed a YouTube video. Should be up soon. It's the first episode of the reverse dieting series. So all exciting things, and we're literally going to jump straight into the science. So last episode, we talked about, let me start here. 2 episodes ago, we talked about the entire molecular signaling pathway that occurs in response to resistance training. Last episode, we identified a couple of potential regulators of that pathway, and I kind of left you guys with the thought of what determines how these regulators are expressed is simply due to genetic differences, and you cannot control those. So today's episode is all about the genetic differences between us and how those affect how we respond to resistance training, to exercise, how our strength, size, and just overall exercise performance is affected in a general sense by our genetic variation. So when we talk about genetics and inheritance, genetics is the study of transmission of traits across generations. And quantitative traits exhibit a large amount of inter-individual differences, and they persist even into homogeneous groups. So if you think about taking an entire country and trying to look at the differences between people in like quantitative traits, like, I don't know, like BMI and size and height and weight and whatever, that's going to be a huge amount of variation. And you can try to put them into homogeneous groups, such as group them by sex, group them by age, group them by body mass. And within those homogeneous groups, you're still going to have a huge amount of individual differences in these traits because we all have such different genetic bases and genetic foundations. And so the challenge that we're presented with is trying to understand what is driving the association between genotype and phenotype. Because sometimes knowing someone's genotype is not sufficient at predicting their phenotype. I can know your genetic basis, but just because I know what's in your DNA does not mean that I can predict exactly how that DNA is going to be transcribed into mRNA, how that mRNA is going to be translated into protein, and how that protein is going to eventually be expressed. Because there's a number of different regulatory processes that occur between DNA and protein that can still alter the amount or the manifestation of your DNA, of your genetics, even if I know exactly what your genetics are. And some of the things that regulate anything in the process from DNA to protein, we have something called epigenetics. And epigenetic modifications, to keep it simple, is essentially, like very simplistically, the addition of certain methyl groups that either open up or close up parts of your DNA that allow them to be easily expressed or less easily expressed. And that alters the amount or the expression of certain proteins based on their epigenetic modifications. And that's not written in your DNA code because the DNA code is what's either being overly or underly expressed via epigenetic modification. Your environment can affect your phenotype. Cellular tissue energy status or nutrition status can also affect the phenotype. Certain pathways are going to be upregulated or downregulated based on nutrient availability or just general ligand availability, regulator availability. Anything that that pathway may need, the availability of that is going to affect how that pathway occurs. And then just also the role of just alternative pathways. All of these things happen after DNA. So again, sometimes knowing somebody's genetic basis, genetic code, DNA, all of that is not necessarily sufficient to perfectly predict someone's phenotype. And in science in general, there's that challenge of how can we predict a phenotype based on a genetic code? We have really solid association. So we know if you have, like I said last episode, if we can see in your DNA that you have a loss of function mutation in the gene encoding for myostatin, we know that you're probably going to manifest in an unregulated hypertrophic pathway that results in greater muscle mass, greater size, greater all of that. However, we can't perfectly predict that, and we can't perfectly predict how every gene results in a specific phenotype. So when it comes to skeletal muscle phenotypes, there's evidence that suggests that there's obviously a significant genetic component to human variation in skeletal muscle strength. There was a Canadian fitness survey done on 13,804 subjects looking at strength and endurance, and they looked at max number of sit-ups in 60 seconds, max number of push-ups, and hand grip strength. And they wanted to see kind of what percentage of these outcomes was determined by genetics. And they reported heritability estimates, meaning what percentage of your outcome in each of those specific tests was most likely due to traits you inherited, due to your genetics, not to training, not to this, not to that. And they found that this heritability estimate was 37% for sit-ups, 44% for push-ups, and 37% for grip strength. So we're talking between a third and just under a half of your performance in these specific metrics is estimated to be due to your genetics, to your inherited traits. There was another study that we looked at called Familial Aggregation of 7-Year Changes in Musculoskeletal Fitness. It was published by Kaczmarzyk et al. In 2001. And essentially, they're looking at the degree of familial resemblance in baseline and 7-year changes in musculoskeletal fitness. So people training essentially for 7 years and then seeing after 7 years, the differences in your musculoskeletal fitness, size, strength, musculature, whatever, the differences after 7 years, how much of those were due to the 7 years and how much of those were due to just your genetics, what you inherited from your parents. And they found that around 54 and 63% of variance in 7-year changes can be accounted for by family lines. So averaging across the different metrics that they looked at, we're looking at about half of the changes you saw in 7 years could be accounted for by your inherited traits, which is kind of interesting. So if you're happy with your 7-year changes, I guess thank your parents. And if not, maybe have a stern talking to with them. I'm kidding. But that also means that the other half of the changes seen were able to be manipulated through time and hard work and training and this and that. So kind of glass half full, glass half empty, depending how happy you are with your genetic basis, you can choose what perspective you want to take and work really fucking hard because, you know, they're looking at what percentage of variance in these 7-year changes. But if you work really hard, you're going to change even more. And even if only 50% of that is due to the work you put in, 50% of more change is still more change. Does that make sense? I hope that made sense. Anyways, we also talked about skeletal muscle fiber type distribution and how that's a significant determinant of endurance training performance. So marathon runners have a very, very, very high amount of type 1 muscle fibers compared to type 2 muscle fibers. Really, really strong people, really explosive sport athletes are going to have a high proportion of type 2 fibers versus type 1. And everyone is born with a different proportion, a different natural predetermined proportion of type 1 to type 2 fiber ratios. And the human variation in proportion of fiber type is very, very large. This specific study did a bunch of muscle biopsies in the vastus lateralis and looked at proportions of muscle type fibers in sedentary adults who have never trained, just couch potatoes to put it in easy terms. And about 25% of these sedentary adults exhibited either a quite low type 1 fiber type proportion or a really high type 1 fiber type proportion. So it's just interesting how obviously the majority of adults lie between the extremes. So around, you know, a 50-ish% of type 1 to type 2 fiber, like a more equal ratio. It's not going to be exactly 50 by any means, but just a more equal ratio. And you can train your body to undergo fiber type switches. More endurance training, you're going to see more type 1 fibers. More strength training, you're going to see more type 2 fibers. So you can train yourself to change your fiber type proportions, but it is very unlikely that you can train yourself to be on either end of the spectrum. Because 25% of sedentary adult Caucasians exhibited either quite low or quite high proportion of type 1 fibers in their quads. Quite low being 35% or less of their muscle fibers were type 1. Quite high being 65% or more of their muscle fibers were type 1. Meaning Those on the quite low spectrum, you could take them straight from the couch, tell them run a marathon, and there's no shot they're completing it, but you could tell them do a fucking squat, bench, deadlift, and they might out PR most of the people currently in the gym. If you took the people on the quite high end of the spectrum, you might say, hey, try to deadlift this bar, and it's not coming off the floor, but you tell them run a marathon, and they might outrun most people currently in a running club. Like, that's just where their genetic foundation lies. They just have this genetic predisposition to either be better at one specific type of movement versus another because of their fiber type proportions. And we can change our fiber type proportions, but only to an extent. The majority of us exist between these extremes. So not having like predominantly type 2, not having predominantly type 1, not having 50-50 either, but just somewhere in the middle. And if you train exclusively endurance training, you can induce fiber type switches and have more type 1. If you train exclusively for strength and hypertrophy and resistance training, you can have more type 2. But it is very unlikely that through training, you're going to get yourself to either end of the spectrum. Like, you cannot strength train yourself to be at that lower end with the people who just genetically were born that way. And you cannot run yourself to be in that higher end of type 1 fibers where with the people who were just happen to be born that way. So it is a little bit like that last idea of it's almost 50-50 predetermined and 50-50 changed by training and life and environment and whatnot. It's up to you how you look at it. Like, you know that you're never going to be born as one of the outliers. You know if you're born as an outlier. You know that because the outliers who train, they become elite. The people at the low end of the type 1 spectrum that have mostly type 2 muscle fibers, they train and they become elite weightlifters, powerlifters, sprinters, jumpers, anything really explosive. Athletes, like sports athletes. You take people at the really high end of the spectrum with high type 1 fiber proportions, they train and they become elite marathon runners. Some people will never know that they're an outlier if they simply never train. Because those differences are really going to be elucidated if you give them the opportunity to be elucidated. But if you're active, and I'm assuming if you listen to this podcast, you resistance train, you engage in some kind of physical activity, you would probably know by now if you have a really great genetic predisposition to either be really strong or have really good endurance when running or this or that. So if you know that you're kind of probably not a genetic freak, so to say, probably not genetically blessed, as we like to say, probably not an outlier on the spectrum of fiber type proportions, then it's up to you if you want to look at the glass half empty, glass half full. You can beat yourself up and be like, oh my God, I can never train myself to be the next world champion in this sport or world champion marathon runner. But you can also focus on the fact that you can switch your fiber types. If you resistance train enough, you can still improve your current proportion of type 2 to type 1. On the other hand, if you want to be a runner, if you run enough, you can increase your current proportion of type 1 to type 2. So I encourage you to not take this as like I'm shit out of luck because I already know I'm not one of those, outliers. And so, I mean, I can train and I can change, but I'll never be able to get to where they are because at the end of the day, some of those people who are genetic outliers don't train at all and will never know it. So your focus should always be to be better than your current baseline. And wherever you fall on that spectrum, try your hardest to improve it in whatever direction best suits your goals and your sport and your this and your that. So when studies were looked at collectively and they were examined collectively, it suggested that a genetic component accounts for about 45% of variance in the proportion of type 1 muscle fibers in humans. So, that the previous numbers we were looking at were based on those muscle biopsies in the vastus lateralis. But when you look at studies collectively and you combine a bunch of data, the kind of percentage of variation that's accounted for by genetics is about 45%. So about half of your current type 1 muscle fiber proportions are determined by your genetics. But again, that leaves, it's 45%. So that leaves more than half of that to be determined by your actions, by your training, by your nutrition, by everything else that you do. So essentially, genetic variation does have to do with this human heterogeneity that we see in skeletal muscle phenotypes and performance outcomes, but it's not the only cause. So if you kind of want to limit yourself because you feel like you just don't have the genetic capacity to ever be elite or this or that, don't. Because from what we're seeing, yes, genetics can account for almost approximately about half, but it's under half. So if you want to look at the other side of the coin, that means over half, over 50% of your outcomes, at least when it comes to muscle fiber type proportions, are determined by what you do. So you're going to leave over half of your potential changes on the table if you decide to give up because you just feel like your genetics are working against you. So what's the point? Anyways, so again, yes, about 45% of this variance in the proportion of type 1 muscle fibers is due to genetics, but over half is not. And there's other inter-individual differences that were also found. So differences in enzymatic activity. So the activities of enzymes, and those enzymes can be regulated via any of the differences that we've discussed. microRNA expression can regulate certain pathways that then change the amount of enzymes expressed and therefore change the levels of enzymatic activity that can then affect your fiber type proportions or your strength outcomes or your hypertrophy outcomes. So again, it's not just at the genetic level. It's not just embedded in your genetic code. What's embedded, what's pre-written in your genetic code determines a lot. But there's so many things that happen that need to occur to go from genetic code to the actual phenotype that can potentially be more in your control. A large part of it, do not get me wrong, is determined by genetics, but a large part of it also is more in your control. So other than that, after we kind of discussed genetics, we went into the regulatory proteins that we discussed last episode. So that's pretty much what I have for this episode. It's just a little reminder that genetics do play a large role in the differences that we're seeing. So if you're working really hard and you feel like other people are just responding better, don't beat yourself up. It's not that you're not working hard enough. But on the flip side, don't get discouraged because your hard work is not for naught. I mean, if I'm averaging all the numbers that we've looked at, we're pretty solid in the fact that less than half of our phenotypes, when it comes to skeletal muscle phenotypes, all of that, less than half are determined by genetics, and TBD what determines the other part. But a part of that is going to be your training, your hard work, your nutrition. So in my opinion, and if you take anything from this, it's don't beat yourself up if you're not progressing the way others are, because you guys have foundational genetic differences that are going to impact the way that you respond to training. But also don't beat yourself up because of that, because your hard work, your training, your nutrition does play a large role in your outcomes still. They just might manifest a little bit differently or take a little bit longer or be to a lesser magnitude, but they're not doing nothing. So keep training, keep believing in the work. You guys know that I will never stop believing in the work. So yeah, that's what I have for you guys. Let me know if you have any questions. As always, you can email thevaliditypodcast@gmail.com, DM my podcast Instagram, DM my personal @VallFitt_IFBB Pro. Be on the lookout for my reverse dieting series on YouTube. And my new one-on-one coaching application is live and in the description below. Otherwise, if you are interested in being a subject in the world's first reverse dieting study, please email reversedietstudy@gmail.com. And otherwise, let me know if you have any questions. I hope you guys enjoyed. I hope this made sense. And I will see you in the next episode.